Welcome to another Mr. Paul video. I know this video is a little bit harder to see because of the glare, but today we're talking about sets of real numbers. This is section 1.2, sets of real numbers. Now, when we say real numbers, we don't mean real and fake, we mean the set of reals, okay? And to illustrate what exactly that is and all of the other sets, what I've decided to do is make this box and create an analogy for you. You'll notice that I made a box here. And I'm going to be making a reference to science to help us understand exactly how the sets fit together. So in this lesson, we'll be discussing what are some of the sets and how do they fit and connect with some of the other ones. So let's start with the parallel that I'm going to create. We're going to pretend that we're in space. And this box is going to represent the entire universe. The entire universe. Now, the universe, as you know in science, is absolutely everything. It's everything that could possibly be there. And we're going to pretend that this box represents the universe. Okay? From this box, I would like to separate it into two different categories. Now, obviously, things are not going to be drawn to scale. This whiteboard doesn't represent exactly how big the universe is, but you get the point. And I'm going to separate it into two different sections. We're going to say that this side will be the Milky Way galaxy, which is, by the way, where we live. We live in the Milky Way galaxy. And then we'll say that this side represents all other galaxies. I think that's how you spell that, galaxies. Don't get mad at me if I spelled that wrong. So this is the galaxy that we live in, and this is the rest of the universe, right? This is everything else. Now, inside the Milky Way galaxy, which is the cluster of planets that we live on, we have this place called home, and it'll look something like this, and we'll call this Earth. Okay, Earth is inside the Milky Way galaxy, just like this blob here, which is kind of like Earth, is inside this section labeled the Milky Way galaxy. Now, as more specific, on Earth, we have this place we like to call Sacramento. Now, this Sacramento blob is located inside the Earth blob, and this Earth blob is located inside the galaxy side, and inside this Milky Way galaxy side is inside the universe. So what does that mean? It means that this little speck of me, let's just say this is me. Mr. Paul lives in Sacramento. And because this blob is inside the other blob, I live in Sacramento. Therefore, because Sacramento is on Earth, I also live on Earth. This me lives in Sacramento, and I also live on Earth. Because I live in Sacramento, which lives on Earth, which Earth is a member of the Milky Way galaxy, you could say that I also live in the Milky Way galaxy. You can also say I live in Sacramento, I live on Earth, I live in the galaxy, but I also live inside the universe because the universe is everything here. What you cannot say is that this little speck of me lives in some other galaxy. You cannot say that. I don't live in some other galaxy. Okay? You cannot say that somebody else on Earth, let's just say this is Bob from New England, right? This is someone in not New England, in just England. England is a different place on Earth than Sacramento. If you lived in England, you can say that you are on Earth and you are in the Milky Way galaxy and you are in the universe, but you cannot say that you're in Sacramento. There are lots of other places on Earth that are not part of Sacramento. There are lots of other places of the galaxy that are not on Earth, such as Mars, such as Jupiter. You get the idea. Because you live on Mars doesn't mean because you're in the Milky Way galaxy, you're somewhere on this side, does not mean you have to live on Earth, does not mean you live in Sacramento. This is what's known as subsets. When you live inside here, you automatically belong to this piece. And because this piece is inside here, when you live here, you belong here and here and here. Now, how in the world does that relate to math? Well, let's introduce some of the sets. Okay? The universe, we can think of this as the reals. Okay? And what the reals are is basically any number that we write down. It contains a whole lot of stuff. It's all of the numbers that we know. All of the numbers. Okay? And it includes everything. Well, what are these partitions here? Well, we can think of the Milky Way galaxy as the rationals. And we can think of these other galaxies as the irrationals. Remember, the universe is made up of two different sets, the rationals and irrationals. They come together to create the reals. Now, things on the irrational side are things like square root of 3 or pi. Or things that continue on like 2.416.3 ... They go on forever without a pattern. And we talked about that already. The rationals are the numbers that we talked about that can be turned into fractions. Things like whole numbers or fractions or decimals. All of those are included in the rationals. But just like Earth, they're more specific. Earth is a section of the rationals. It's a more specific section. And the Earth can be thought of what's called the integers. And we can think of these as the complete numbers. They are the numbers on this number line that you see here. 25, 24, 23, 22, and it goes all the way to 0, and it includes all of the negative numbers too. Things like -10, 0, or 5. These numbers here that are on this number line are also a member of the rationals because they can be turned into fractions. These numbers here, these integers, are rational, but they're also real. What you cannot say is the integers are a member of the irrationals. You cannot say that. Well, then what is Sacramento? Sacramento is what's called the whole numbers. And we can think of these as like the positive integers, okay? Or the counting numbers. So we'll say counting numbers. And they are like 1, 2, 3, 4, ... It's the numbers on this number line, but only the positive ones. So a whole number is positive, complete numbers, only the positive ones. All of these numbers, they call them elements. All of these numbers that you can think of, the positive numbers on this number line, are all integers. All of these numbers are integers, and they're also rational. All of these numbers are whole, integer, rational, and real. So how does that help us? Well, when you're trying to categorize sets, all of these numbers are a member of this set itself, but they're also a member of the integers. All of these numbers are a member of the integers and the rationals. All of these numbers are a member of the wholes, the integers, the rationals, and the reals. So we're trying to decide what examples can we use to help us decide which sets they belong to. So let's do a couple of examples. Let's just take the number 4. I know it's listed here, but this is how we can decide what set it is. We are going to list the sets that it belongs to. We're going to start with the outwardmost set. Is it a number that's all of the numbers? Well, sure. So we can say it's a member of the reals. And then we have to make a decision. Is it rational or is it irrational? Well, since it can be turned into a fraction, right? It's listed on this side. We could say it's also a member of the rationals. Since it's rational, can it also be considered an integer? Is it one of the numbers on this number line, positive or negative? Well, sure. We can also say this is a member of integers. Lastly, is it in Sacramento? Is it one of the whole numbers? Is it positive counting numbers? Yes, it is. It's also a member of the whole numbers. It belongs to 4 sets because it lives in Sacramento. Because it lives in Sacramento, it lives on Earth. Because it lives on Earth, it lives in the Milky Way galaxy. Because it lives in the Milky Way galaxy, it's a member of the universe. What about the number -2? For example. Well, is it a member of the universe? Well, sure, of course. It's a number that exists. It is a real. It is rational because it can be turned into a fraction. This is -2/1, so it's also rational. Is it an integer? In the complete numbers, positive and negative? Well, sure, it's -2, so we could say that it's an integer. Is it a member of the whole counting numbers, the positive ones? No, -2 is negative. So I have to stop. I can no longer declare that it's inside this bubble because it's on the outside of that bubble. It does not meet the criteria to be part of another set. Does that make sense? So I stop. What about the number square root of 5? Because square root of 5 is not on that perfect square list, I know it's irrational. I know it's irrational because square root of 4 is on the list and it's 2. Square root of 9 is on the list, that's 3. And it's somewhere in between there. It could be, 2.1 something, something, something. But when I decide, okay, is it a real? Yes, sure it is, real. Is it rational or is it irrational? Since it's not on the list, we know it's irrational. And you'll notice there's no other sets on this side. I can stop. Once you've decided it's irrational, it can no longer be a member of Earth or Sacramento, meaning it can no longer be a member of the integers or the whole numbers. If you live in some other galaxy, you still can't live on Earth. You can't live in Sacramento. Okay? This is how sets work. What they call it is Sacramento is a subset of Earth, and Earth is a subset of the Milky Way galaxy, and the Milky Way galaxy is a subset of the universe. You'll be learning more about sets and subsets next year. But hopefully this galaxy reference kind of gives you an idea about how some of these sets fit inside of each other, and how all of the members, all of the items listed in Sacramento are in Earth, and all of Earth is lived inside the galaxy. Similar in a way, the whole numbers are subsets of the integers, and the integers are subsets of irrationals. And they, together with the irrationals, make up the reals. That's it for today's video, guys. I know it's a little bit confusing, but hopefully it brings some sort of clarity to how the sets fit together. Peace.